Hello and welcome back. Today I will tell you about how oil and gas fields are formed. In my previous lectures, I already mentioned that commercial deposits of oil and gas are found mostly in sedimentary rocks, sands, sandstones, limestones, dolomites, which are good reservoir rocks for liquids and gases. We should mention that contrary to popular belief, there is no such thing as oil lakes or rivers. Oil is contained in so-called petroleum traps. Formation of oil is a lengthy process that consists of several stages and lasts, according to various theories, from 50 to 350 million years. Beds of sedimentary rock pores and fractures or ditches filled with petroleum fluids are called oil or gas-bearing formations and make deposits of oil and gas. A group of oil and gas deposits located within the same area and attributed to the same tectonic structure is called an oil or gas field. For a petroleum field to form, the following elements must be present: reservoir rock, seal or cap rock, source rock, carrier rock through which oil can flow, trap, time. Let's cover each of these elements in detail. Reservoir rock is a rock that contains pores, caverns, or fractures. That is, void space between the rock grains, the oil, gas, and water can be contained. Most reservoir rocks are sedimentary. Reservoir rocks might look like parallel beds, lenses, channels, etc. The shape and properties of reservoir rock depend significantly on the depositional environment. We distinguish three major environment types: continental, coastal, and marine. Each of these types can be further subdivided into subtypes. Each sedimentary environment has its own features, bodies of rock with distinctive characteristics such as mineral composition, sedimentary structures, stratification character, etc. Depending on particular features, we can guess about probable spatial distribution of reservoir properties, about presence of anisotropy, a phenomenon where rock properties are different in different directions, about correlation between porosity and permeability, about reservoir rock structure, shape, and probable size. Today's reservoir rocks were formed in ancient times, millions, tens of millions, and even 100 million years ago. A time period during which sedimentary rocks were deposited in certain geological conditions is called an era. Eras are subdivided into periods, epochs, ages, and chrones. Each period was characterized by its own flora and fauna, so fossil remains of these animals and plants are used as distinctive feature for rock formation classification purposes. Mutual arrangement of these rock formations in the earth crust is called stratigraphy. As earth crust is moving, some formations subside into the sea, while others rise to the surface. Geologists describe this formation and put together stratigraphic tables. What we need to keep in mind is that different forces are typical for different geological periods. We can use this information to deduce the period when this particular rock was formed and conclude whether it can be reservoir rock or not. Seal is a fine-grained impermeable rock formation that keeps oil and gas from escaping to the earth's surface. Salt formation can make great seals, but most cap rocks are shelled or silts. Nowadays, the best established and acknowledged theory of petroleum origin is the so-called organic or biogenic theory. According to this theory, oil originated from the remains of microorganisms that populated extensive shallow water basins millions of years ago. As they were dying, these microorganisms subsided to the bottom, building massive accumulation of organic matter. As time was passing, you do remember that it makes millions of years. These accumulations were subsiding deeper and deeper, and the deeper they bubbled, the higher pressure and temperature they had to bear. Due to biochemical process that happened in absence of oxygen, organic matter was turning into hydrocarbons. The rock the generation of hydrocarbons took place is called source rock. This is sedimentary rock rich in organic material and capable of generating hydrocarbons. Different types of organic matter result in different hydrocarbons. Plant fossils end up as gases, while animal fossils tend to generate heavy hydrocarbons, that is oil. Also, the type of hydrocarbon generated depends on temperature, burial depth, and the time of exposure to temperature and pressure. It is similar to cooking food. You need to apply heat, but be very careful or you will burn your dinner. After generating hydrocarbons, the mobile fluid was slowly migrating through permeable rock from high to low pressure area. In most cases, this means flowing up. It kept on flowing until it reached an impermeable formation which stopped the fluid from further migration. The rock through which the hydrocarbons were migrating is called carrier rock, a permeable rock that allows flow of hydrocarbons from the source rock to the reservoir rock. Often, the carrier rock itself is a part of reservoir rock. A trap is a structure that blocks the movement of hydrocarbons and causes them to accumulate. It consists of reservoir rock with impermeable seal on top. As hydrocarbons migrate into the trap and accumulate there, the oil field is formed. There is always some water in any oil, but as oil is typically much lighter than water, it always rises on top. If there is gas present, it will rise above both oil and water. In some areas, hydrocarbons did not encounter any traps at all during migration. They reached the Earth's surface, there they were destroyed by the environment. However, no oil lakes can be found underground. No matter what you may have heard, oil is contained in traps. Traps may be of two types, structural and stratigraphic. Structural traps are caused by tectonic processes, gravity, and rock compaction. Tectonic traps are formed some time after the reservoir rock was deposited during movement of the earth crust, which cause faults and faults. Sedimentary formation that used to lay flat due to tectonic process rise or fall relative to one another and form faults of various shapes. Faults that fall upwards are called anticlines, and the ones that fall downwards are called syncline. Most petroleum traps in the world are anticlinal traps. Besides anticlines, monoclines are also good in terms of petroleum trap formation. A monocline is a structure in which all layers are similarly inclined in the same direction. When faults are formed, formations usually do not break. Yet sometimes tectonic processes can tear a formation in two, forming a fault, and the two parts shift relative to each other along this fault. They can form different structures such as throws, thrust and faults, other thrust faults, downthrow and upthrow blocks. The last but not the least element is time. Every process related to petroleum field formation requires time. First, source rock needs to be formed and buried, then organic matter needs to turn into hydrocarbons. Petroleum needs to migrate into the trap, and finally enough hydrocarbons must accumulate in the trap. It is very important that the trap is already in place, then hydrocarbon migration starts, or nothing will keep them from coming up to the Earth's surface. This is all for today. See you!